Welcome to Tank Radio. I'm Frank, KG5HJ, and today we're going over solar charge systems, starting with types of batteries, basics components of the system, and some basic math to help you figure out how much battery amperage you need. So play that awesome intro video. It's time for another basics video. You know what that means? Paint time! Yay! We are going to be looking at 3 different battery types. Lead acid batteries, lithium phosphate, and lithium polymer. These 3 battery technologies is what you usually find if you're looking for a off-the-shelf battery to use in amateur radio. Let's go ahead and start talking about lead acid batteries. Are commonly found in cars. This is because they have a high recharge rate and a high discharge rate, what makes them perfect to be run in cars when you have a starter that needs a lot of power to turn over that engine. The drawback is with them, they're super heavy. Let's talk about lithium polymer batteries next. These batteries are super dense in energy capacity, and they're also light. But the same thing that makes them dense in the energy storage capacity is if they're discharged too fast or recharged too fast, the energy density is very excited and has a chance of exploding. Lithium phosphate batteries are commonly found in the amateur radio technology. I got one right here. These batteries are lighter than lead acid batteries, but not quite as light as lithium polymers, but these usually differ a pound or two between the phosphate and the polymers. They're also less dense volume per energy stored because they need more material for that energy to be stored. But they are more resilient than the lithium polymers, and this is why I'm choosing this one. So to recap, I'm not going to be doing the lead acid because they're too heavy, and I want to take this battery hiking with me so I can sleep overnight. The lithium polymer is a lighter battery and more densely stored energy, but if you not use them properly, or you puncture them or jostle them too much, they will probably catch fire, and this is why I'm going to rule those out for myself. What I'm going to go with is the lithium phosphate battery. This is because they are very energy dense, but this type of battery is more resilient, can hold up to a little bit more abuse than the polymer. You don't need to get too crazy, but they take a little bit of a beating. Yay! So this is what you're going to need for a system. You're going to need a battery. You're going to need another device called a charge controller. We'll get into that in a minute. And then finally, since I want to use this system over and over again, and I want to recharge the battery when I'm out and about, probably on a hike, hopefully summits, soda on the air one day, I'm going to use a solar panel. In my case, I'm going to be using a foldable solar panel that I could put in the backpack. The basic design is these 3 devices. As you would have guessed, battery is going to hook into the charge controller, and then the charge controller is going to hook into the solar panel. The charge controller is going to regulate the amount of current we're drawing from the battery, and also regulate how much current we're putting back in the battery so that we don't overcharge or over pull the battery, to keep the battery in a healthy capacity so it doesn't overheat. From the charge controllers, depending on which ones you get, you can have your devices hooked directly into it. In my case, I'm going to be hooking up a CPAP machine so I can breathe at night. The other common setup is this charge controller can be a simple device, and then you can run your devices straight from the battery. But when you do this, you need to monitor the current that you're pulling from the battery to make sure it's in a safe capacity. Majority of times you can put devices on this wire that tell you the current load, and you can monitor that yourself. Next, I need to do the math. How big of a battery do I need? I have purchased a 12 volt converter to my CPAP machine. Next, we need to figure out how much amperage the CPAP machine uses while it's on. Right now my Elenco 30A power supply is in a amp meter mode, so I can see how many amps the machine's drawing. Right now it's showing just shy of 2 amps. That's with the hose wide open. If we go ahead and shut it off, it's almost down to 0. Bounces back up. But at night, this is not how I breathe, so I need to find some type of analog. Now with the analog, the needle seems to be jumping between 1 and 2. We can name them later. So from the amp test, we found, and let's be conservative here, the device is pulling somewhere between 1.5 to 2 amps. We can't really be certain because the needle was bouncing, but let's just use these numbers. So let's use both of these. So this would give us a mid and a high end or low end of amperage that we need to complete my goal. I would like to have a night and a half of sleep with this system. So that would be about 9 hours on the first night, let's say 4 hours on the second night, so that would be, I need 13 hours. So with the high number, we need a system to have 26 amp hours. On the low end, 13 times 1.5, 19.5 amp hours. So I'm going to need a 20 amp hour battery to fall into this middle ground just a bit, because they don't sell 26s. I'm going to be on the low end of the scale of where I want it, but that's the best I can do with our current battery technology and not have it break my back as I'm going up a hill. Let's figure out how long it's going to take to recharge the battery after it's been depleted. The battery itself is 20 amp hours. Then we're going to divide that by how many amps our solar panels generate. For example, let's say that the solar panels produce 3 amps. So this will give us a charge time, 6 hours, 6 a lot. So if the system was down, on a bright sunny day in 6 hours, I could have a full charge. So let's just say I use the system on a single night and I use on average 1.5 amps an hour. We're going to get a calculator out for this one. So 1.5, and I slept for, let's say, 9 hours. It was an awesome night, so I used 13.5 amps. Then we divide that by 3, because that's how many amps the solar panels use. The system itself will be charged in 4.5 hours. Plenty of time to also hook up in radios and use it throughout the day, and still have a fully charged system by the time I need it at night. Or if it's a not as sunny day, you know, this can be longer to charge, but I only need to put half the power back in to get another night's of sleep. So I don't need a bright sunny day, a half sunny day. Just charging the battery alone will give me another full night. And that is my idea. So we'll see how that works out. How do you spell resilient? That's the best I could do. I had a clever line. I thought of it in the car, and I can't think of it now. Oh well, it's gone.